Hi my dear students, welcome back to the class. Today we are going to learn a new concept. Actually this is not a new concept for you because you learned this thing in your 10th class. But coming to the 11th class, we are going to learn these things in a new manner or in a new perspective. And the name of the chapter is nothing but trigonometry. Of course you know this thing, right? You know sin theta, cos theta, tan theta. Of course you know what is theta, and you know cot theta, cosec theta, sec theta, and you know some identities using that, right? But still you don't know why did you learn these things. I mean, some may tell that you can easily calculate distances on the heights, or you can easily convert some degree measures to radian measures, and still you don't know why these things or how we can perform these things in a most simple way using trigonometry. And during these sessions we are going to say why we learn these things and how we can interpret these things using trigonometric functions, using the actual events using trigonometric functions, and how trigonometry enables us to do real life problems in a really simple manner. So, in order to begin the chapter, we shall operate the name itself, that is trigonometry. See, trigonometry basically formed with three words, right? Trigonometry. See, this trigonometry is formed of these three words. Actually, these three words itself convey what trigonometry means. See, first word is nothing but tri. This means that 3, right? You know that. So the first word in the name trigonometry means 3. Now the next word is nothing but gono. Gono is a Greek word which means angle. So the second word means angles, and the third word is nothing but metry. And metry means measure. So you can easily now interpret what is trigonometry. Trigonometry is basically composed of three words, and the three words are 3, tri means 3, gono means angle, and at the last metry means measurement, which means that trigonometry is nothing but something, a branch of mathematics which deals with measure of three angles. So trigonometry is nothing but a branch of mathematics which deals with measure of three angles. Now of course you know the geometrical figure which gives us three angles. What's it? A triangle. So trigonometry basically deals with a triangle. But there is a problem. Trigonometry cannot operate all the types of triangles. You know, different kinds of triangles like isosceles triangle, equilateral triangle, right angle triangle, etc. Trigonometry only deals with right angled triangle. So the most liked area of trigonometry is right angle triangle. That is, trigonometry is the branch of mathematics which deals with the measure of three angles in a right angle triangle. So now you know what does trigonometry means. ആര് ചോദിച്ചാലും ഇനി ട്രിഗ്നോമെട്രി എന്താണ് എന്ന് ഡയറക്റ്റ് ആയിട്ട് പറഞ്ഞോളുക. ഇറ്റ് ഈസ് എ ബ്രാഞ്ച് ഓഫ് മാത്തമാറ്റിക്സ് വിച്ച് ഡീൽസ് വിത്ത് ദ മെഷർ ഓഫ് ത്രീ ആംഗിൾസ്. ആൻഡ് which three angles? The three angles of a right angle triangle. Now the question arises, what we can do when the triangle is not a right angle triangle, or how will we deal with a non-right angle triangle? Suppose that our triangle looks like this. What we can do? See, this is very simple, since this triangle can be splitted into two right angled triangles. You can see now this is a perpendicular by angle bisector, so that this and this are right angle triangles. So this triangle and this triangle are right angle triangle. Now our trigonometry can easily operate this entire triangle by its tools. Which are the tools? You know, sin theta, cos theta, tan theta, etc. Let it be there. We can discuss about it later. Now, trigonometry is the branch of mathematics which measure of three angles in a right angle triangle. Again, the question arises, what is the angle? What is an angle? This is a great question. Of course, we are discussing a lot about angles, three angles, a square has four right angles, and a hexagon has six angles, etc. But still, most of us don't know what is an angle. Let us discuss about angles at the first. So, in order to define an angle, we need a ray or a line. Suppose that we know that an angle is formed in between two lines. So, in order to define an angle, I am just starting with a directed line segment. See, this is a directed line segment. Since it is a directed line segment, it must have an initial point and a terminal point or a direction. See, so this is the directed line segment with which I am beginning with. Now, suppose that I am fixing this point using a pin like this. I just fixed this point here and I picked this point and I begin to rotate this entire line segment about this point. Suppose that after rotating I reach the ray in this position. See what happened here? I just rotated this entire line segment about this point. If you feel difficulty in visualizing this, just see this. Here we are rotating. Here we have a ray and we are rotating this ray about its original or initial point, right? So, after rotating, my ray reaches a new position, right? Before rotating, before we started to rotate, the original position of ray is this, and I am naming this side of the ray as initial side, and the position which obtained after rotating can be named as terminal side of the ray. So, what is initial side and terminal side? Initial side is the original position of the ray, whereas the terminal side is the final position of the ray after our rotation. So, now we know what is the initial side as well as the terminal side of a ray. See, here the amount of rotation performed can be measured in terms of this angle. See, angle can be thus defined as the amount of rotation which is performed in order to reach the initial side of a ray to the terminal side. So, angle is nothing but, see, this measure enables us to define or enables us to calculate the amount of rotation we have to be performed in order to reach the terminal side or the new position of the ray. So, in simpler words, an angle. So far we were discussing about an angle. So in short, an angle can be defined as the amount of rotation we have to be performed in order to reach the terminal side or from the initial side of the ray. So this is considered to be as the angle. Let us name this angle as theta. So theta is nothing but the name of the angle, just like a number. So this is considered as to be theta. Now observe that here the rotation is of anti-clockwise movement. You know that clockwise movement goes like this and anti-clockwise movement goes like this. So here the rotation is anti-clockwise. In that case we take theta as positive. So the angle will be positive if the rotation of the initial side of the ray to the terminal side of the ray is clockwise. So clockwise rotation, sorry, anti-clockwise. The anti-clockwise rotation result in positive angle, whereas angle is the amount of rotation needed to be performed in order to reach the terminal side of the ray from the initial side. Also remember that the terminal side is nothing but the new position of the ray after rotation. So we have theta positive. Now you can easily define when will theta will be negative. Suppose that if I am rotating the ray clockwise, the new position of the ray will be like this. See, this is the initial side here, this is the terminal side here, right? So here the angle theta is measured in anti-clockwise direction. In that case we take theta as negative. So an angle is considered to be positive when the rotation of the ray is anti-clockwise, and an angle is said to be negative or considered to be negative, or the rotation or the direction of the rotation should be in clockwise direction. So I hope you understood what is the angle and what is the initial side of the ray, what is the terminal side of the ray. Also remember that suppose that I have a ray like this and I am rotating this to the entire way around such that the ray reaches back to the original position, then we can say that the entire angle is that, and also we can say that the initial side and the terminal side coincide. So for a ray, if it has completed a complete revolution or complete rotation to reach back to the initial side, then we can say that the ray has initial side and terminal side are coincided or have the same initial side as well as the terminal side when the ray completes a complete revolution. A complete revolution thus means starting from here and rotating to reach by here. This means a complete revolution. So this is the case of complete revolution. So just remember this is very important, revolution. So the complete revolution means we are beginning a ray from the initial side and rotating all the way around to reach back to the terminal side. Thus we have learned what is an angle, or we are now able to define an angle as the amount of rotation we have to be performed in order to reach the initial side of a ray to the terminal side of the ray, right? Now we can now give units or how we can measure an angle. We know that length can be measured in centimeters or in meters or in kilometers, right? Or we know that the weight can be measured in kilograms, mass can be measured in kilograms, milligrams and grams, etc., right? Which means that every quantity has a measurement unit. Now the question is, what is the measurement unit for angles? So now we are going to discuss what will be the measurement unit or what is the measurement unit for angles. So far we were discussing about angles and we defined angles, and now we are in a position to define the two methods. There is two important methods to measure an angle. So we are going to define the two important methods to measure angle. The first measure for the measurement of an angle is called the degree measure. So degree measure is the first measure in measuring the angle. You know what is degree measure. Actually you used degree measure in your older classes, 10th class, etc. So you know how to use the measure, degree measure. You say that 45 degree, 60 degree, 30 degree, 90 degree, etc. But most of us don't know what is the underlying concept behind the definition of degree measure. Here we are going to define that. We know that angle is the measurement of the rotation we have to be performed in order to reach the initial side to the terminal side. Okay, if the rotation also we know that a complete revolution means a rotation all the way around so that the terminal side also comes to the initial side or coincides with the initial side, right? Now 1 degree is defined as the amount of rotation which is equivalent to 1/360th of a revolution. So 1 degree can be defined as the amount of rotation which has to be performed, which is equivalent to 1/360th of a revolution. So the 1 degree measure is nothing but a rotation which is equivalent to, suppose that I am rotating this ray about this point to reach a new point like this. If the amount of rotation is 1/360th of the entire revolution, then we can say that this angle is 1 degree. So 1 degree is very simple to understand. 1 degree is nothing but the amount of rotation which is equivalent to 1/360th of a revolution, and we know that a complete revolution means starting from here and reaching back here, and if the rotation is 1/360th of the entire rotation, then we can say that the amount of rotation is the angle in that rotation is 1 degree. degree. Also note that 1 degree is again divided to 60 minutes. So 60 minutes constitute 1 degree. Also 1 minute is nothing but 60 second. So second, minute and degree, which means that 1 degree is 60 minute and 1 minute is 60 degree. These are two very important quantities to do problems. So remember this thing very well. So we get 1 degree, 1 minute, and we also defined 1 degree. What is 1 degree? It is the 1/360th of a complete revolution. Now here you can see some degree measures which we oftenly use: 360 degree, 180 degree, 90 degree, and some other degrees are also marked in the figures given below. So just observe these figures and understand this. Very basic concept is nothing but what? 1 degree is the amount of rotation which is equivalent to 1/360th of a revolution, so that we can draw 90 degree, 60 degree, etc. just like this. So remember these degrees very well, and the drawings of these degrees are very important because we are going to do problems based on this. So always remember that 90 degree, of course from the very basic class itself we are saying that this is a right angle and it is equal to 90 degree. Now you can easily understand why we call this as 90 degree, because 1 degree is equal to 1/360th of a revolution. So 90 degree is nothing but 90/360. So 90/360 is nothing but 1/4 of the entire complete revolution. Now 1/4 means, see, the entire complete revolution is here, so 1/4 means thus. So that's why we are calling this as 90 degree. Now 180 degree, we always used to say that this line is 180 degree measure, right? We say that this rotation is 180 degree. Why? Because 180 degree is equivalent to 180 degree means 180 into 1/360th of a revolution, which means that 180/360 it is equal to 1/2. That means that it is the 1/2th of a complete revolution. 1/2 means complete revolution starts from here and reaches here, hence half of it is this, and this is equivalent to 180 degree. In this way we can always, it is possible to derive various degree measures, and it is possible to draw various degree measures like this. So now we can move on to the next very basic measurement which is used to measure angles. The next very important measure for angle is that radian measure. So here we are going to define what is a radian measure. Suppose that we are provided with a unit circle like this. You know what does a unit circle means? A unit circle means, a circle means radius 1 unit. So suppose that I am provided with a unit circle like this, and suppose that this is the arc of length 1 unit. So this is nothing but arc of length. You know what is an arc? So this is the arc of length 1 unit. Then this arc also, this is the radius, this is also a radius, and this is an arc of length 1 unit. The arc of length 1 unit makes an angle at the center, right, isn't it? So this angle is named as 1 radian. So what all are the requirements we have? We need a unit circle, which means the radius must be equal to 1 unit. Also the arc length must also be equal to 1 unit. So the angle, the 1 radian, can be defined as 1 radian is equal to nothing but angle made by an arc of length 1 unit in the center of a unit circle. So 1 radian is nothing but the angle made in the center of a unit circle by an arc of length 1 unit. So always remember that this is the quantity called radian. We need a unit circle and an arc of length 1 unit, so that an arc of length 1 unit makes an angle 1 radian in the center of the circle, which is called the 1 radian. So 1 radian can be marked like this, and whereas this is the arc of length 1 unit and this is a radius of 1 unit, this is also radius of 1 unit. In between that we get an angle, and this is called 1 radian. So here we have an arc of length 1 unit. Suppose that instead of an arc of length 1 unit, suppose that I am considering an arc of length 1/2 units, right? Then suppose that this is an arc of length 1 by 2 units, then the angle made at the center by the radius of the arc of length 1 by 2 unit is nothing but 1 by 2 radian. Similarly, you can define 3 radian, 4 radian, etc. What is the only condition? The arc length must be equal to that. Suppose that I have 1 by 2 unit length arc, then the angle made at the center will be 1 by 2 radian, and so on. Here you can see a list of radian measures which depends entirely on the arc length, because the circle provided is a unit circle, the radius of the circle will be 1 unit. So the arc of length x unit makes a radian x radians at the center for a unit circle. Suppose that I am provided with a unit circle like this, and this is the arc of length x unit, then definitely this angle will be x radian. So for a unit circle, an arc of length 1 unit makes 1 radian, an arc of length 2 units makes 2 radians at the center. Always remember that the circle we chose here is nothing but a unit circle. So now we defined that for a unit circle, an arc length of x radians will subtend an angle, x unit will subtend an angle x radians at the center. So this is our condition. Suppose that this is a unit circle and this is the center and this is the radius. Since it is a unit circle, this is of 1 unit length. Now suppose that consider this as a ray, and suppose that I am rotating this ray all the way around to reach by here, right? This means a complete revolution, and we defined that 1 radian or x radians is nothing but the angle subtended at the center by an arc of length x unit, right? Since when I complete my entire revolution, the arc will be the entire circle, isn't it? The arc length of the entire circle is nothing but 2 pi into r, since it is a circumference. Since r is equal to 1 unit, the arc length will be 2 pi, isn't it? Since after a complete revolution we cover all the circle or all the points in the circle to reach by here, so the arc will be the original circle and the arc length will be its circumference, and it is equal to 2 pi here. So after a complete revolution, the angle subtended at the center will be 2 pi. Since the arc length is 2 pi units, we said that the angle subtended at the center by an arc length of x unit will be x radians. Since here the arc length is 2 pi, the angle subtended at the center is also 2 pi units. So always remember this, that is, after a complete revolution, the angle subtended at the center is nothing but 2 pi units, or 2 pi radian. So if now you understood what is 2 pi radian. 2 pi radian is nothing but the angle subtended at the center of a unit circle after the complete revolution of the radius. Right. Now we shall define what happens, or we shall discuss what happens if the circle provided is not a unit circle. Now suppose that I am provided with a circle with radius r units. Suppose that I am provided with a circle with radius r units. Right. We told that for a unit circle, an arc length of x unit generate an angle of x radians at the center. Here the radius of the circle is r unit. So in order to get 1 radian, we in a unit circle, to get 1 radian, the arc length must be 1 unit, right? 1 unit. Here the radius and the arc length are the same. So for a circle of length radius r unit, the arc length must be r unit in order to get an angle 1 radian at the center. See, r by r is equal to 1. This is the relation. R unit length arc length and the radius is r unit, then r by r is equal to 1. So the angle formed at the center is nothing but 1 radian. So in order to get 1 radian for a circle of radius r unit, we have to take an arc length of r units, so that r by r is equal to 1 and we get a 1 radian measurement at the center of the circle. Now suppose that what happens if the arc length is not equal to r. Suppose that arc length is equal to L unit. Here the radian measure can be easily evaluated by, since 1 radian is, if it is the r unit ആയിരുന്നു എങ്കിൽ ഈ arc length r unit ആയിരുന്നു എങ്കിൽ the angle formed at the center is nothing but r by r equal to 1 radian, right? If the arc length is L unit, L not equal to r, L unit, the angle formed at the center can be easily evaluated by the formula L by r. So the angle formed at the center will be L by r radian, not that if L is equal to r by r is equal to 1. So this is the general condition. Suppose that if we are provided with an arc length of r unit for a radius circle of radius r units, then r by r is equal to 1 and the angle formed at the center is nothing but 1 radian. And now suppose that if the arc length is L, which is not equal to r, then the angle formed at the center can be easily evaluated by evaluating L by r. So if the arc length is L unit and radius is r unit, then the angle formed at the center is L by r radian. So as simple as that, L by r radian. That is, theta is nothing but it is equal to L by r, where L is the arc length. This is very important, just remember this, and r is the radius. Therefore L is equal to r theta. That is, if theta is given and r is known, then arc length can be evaluated using the formula L is equal to r theta. This is also a very important formula. So always remember that. Suppose that I have an arc length of 10 units and a circle has a length 5 units, then the radian measure in between them is nothing but 10 by 5 is equal to 2 radians. Likewise, we can always find out what is the radian measure in between those two radius vectors formed by an arc of length x unit. Just divide x by the radius, or if the arc length is L unit, just divide L by r. Always remember this relation, then you will never get wronged when answering the questions related to radian measures. So this is about it. Radian measure and degree measure. Radian measure is defined as the we can define one radian measure and one degree measure like this. One radian measure is the angle obtained at the center of a unit circle by an arc of length 1 units, whereas one degree measure is 1 by 3/60th of a revolution. These two definitions are very important because in the next class we are going to connect radian and degree measures, or we are going to derive an equation connecting the degree measure and radian measure, so that we can convert. You know that if we are given in centimeters, we can convert it to kilometers. If we are given in seconds, we can convert it to hour. Likewise, we can convert, if we are given an angle in degree measure, we can easily convert it to radian measure. Similarly, if we are given an angle in radian measure, we can easily convert that degree measure, convert that angle to degree measure. Similarly, we can always it is always possible to make conversion between these two measures of angle. So in the next class we are going to learn how we can convert two measures for angle that is degree measure and radian measure. So I hope you understood this class very well. If you have any doubt, just ask me personally or comment here. I will rectify it as soon as possible. And in the next class, as I have told you before, we are going to derive a connection between degree measure and radian measure, which is very important in understanding trigonometry. So till the next class, wait for the next class and rewind this session very well, and stay tuned for the next class. Bye bye.